Okay, guys, I guess we will start.
Thank you.
Not yet. I know that you already saw an entire presentation before, but give us some time. Okay, so this is another presentation about going home after the conference. So I hope that you are not ready to go home yet. We were wondering how many of you had a chance to use Go? Okay, and who of you have a Go in production? You can go. Okay, so just to briefly introduce ourselves, my name is Dudczak, and together with Tomasz, we would like to tell you a bit about our experience with Go. We are not very experienced users, but we had a chance to play with it for the certain purpose. So we are working for quite small company, but we would like to state that these are our own opinion. They are not reflecting the line of the company. In Allegro, you can write your services in different languages, but the language which is introduced to the whole company toolbox needs to integrate well with ecosystem and needs to comply to certain requirements. And we are hoping that Go will comply to those requirements shortly. So who we are. I am a Java developer. With a few years of experience, I work, as I said, for a small PHP startup which is based here in Poznań. In my spare time, I am a member of Poznań Java user group and co-organizer of also a pretty small conference called GCon.
Hi, and I am Tomasz Jackowiak. I also work for that small startup that's called Allegro. And for the past 7 years, I've been maintaining a code base that is mostly in PHP. So I'm a PHP developer. No, nothing. And by now, what I can say is that I learned something that you can love and hate the language that you are writing in. So this is something for me.
So PHP and Java, two languages which you usually keep in the basement. So why Go? From my personal perspective, I wanted to try something which is modern, not like Java. Java has a really long beard. It's a great language. It's a very performant language, but it was designed quite a while. And it's, to some extent, a victim of its own success. And Go was designed for particular purpose, and that's what is interesting from my perspective. It is also much more concise than Java. So these are 2 points which were in first place interesting for me.
Yeah, and as for me, PHP doesn't seem exciting for me anymore. To be honest, there's nothing going on to improve cohesion of the language. And I also like that Ken Thompson's philosophy, the way of creating software, his Unix way of doing things, and the idea that there should be one and only one way to do something right. So I was looking for something fun, fast, but also static typed, and that's something that will reduce the ability to create mess. So yeah, we had our own reasons, not yet, but don't look at us. Let's check what's the presence of Go language in the world. Has anyone of you heard about those projects? Maybe Heka? No, nothing?
3 hands are waving there. 4, 5, 6. Someone's heard.
Oh, okay. etcd from CoreOS, yeah. InfluxDB? Juju? Okay, that's fine. And what about that one, Docker? Yeah, much better. So, we can agree that there are some projects that are popular and they are made in Go. So what about the global popularity of the language? This is the list of most commonly chosen languages based on the number of repositories made on GitHub. And the question is, can we find a Go in top 10? No, not yet. But I think we are going there. At least in the next 2 years we'll be in the top 10.
So it is not a top language. There are some really nice projects written in Go. So why Go? Once again, why are we bothering with the language? And if you take a look at those 3 guys, they're not very happy, but they should be, in fact. And these are creators of Go. So Robert Grismer, Rob Pike, and Ken Thompson. And from that, what I know, these guys have touched virtually any language, which is major one, and is used nowadays. So Ken Thompson was working on B, was working on C. Robert was working on JavaScript and Java. Rob was working, I guess, on everything. So these guys have experience in designing language. They have also experience in creating software. And the thing which they have produced, which is Golang, is quite reflecting the Unix philosophy. So doing one thing and do it well. And they created something which, in our opinion, is quite nice. So just to briefly characterize Go as a language. So it is object-oriented, but it doesn't have a keyword class. So it's a class-free but object-oriented language. It is statically typed, but it has a pretty nice type inference mechanism, which allows you also to have elements of duck typing there. It is garbage collected, it is compiled, so this means it is fast, performant, and on the contrary to C++, the compiler itself is quite fast. And it's open source from up to the bottom. The language itself is BSD licensed, and the open source, it's one of the core values of this. So dependency management is also to some extent based on the, I could say, open source infrastructure. Write runs run anywhere. I guess this is the requirement which you nowadays have for any language, any serious language. And Go compiler is able to compile code for all the major operating system. And as such, comparing to, for example, JVM, Go itself doesn't have its own runtime. So the binaries are quite compact. And
Okay,
nice.
Okay, Adam, thank you. Enough talking, let's show us some code.
Do you know that guy? That's a gopher, yeah, that's a mascot of Golang. From my personal point of view, Duke, the Java Duke, is much more handsome. Maybe if...
But you definitely should look for a gopher in a pilot hat. He's more awesome than...
Yeah, he's sweet. Okay, so I am a Java programmer. What else could I write? Yeah. So that's a Hello World program written in Go, and I wanted to bring your attention to two things here. So in the first place, we have a package declaration, and package main is a sort of convention in Go programs. It tells compiler that this one should end as an executable. Exactly the same as we have in Java, there is a function main, which is the main entry point to the whole program, and the whole printing of the Hello World is not very exciting here. Go run, most of the things are done using Go command. Go command is really powerful. It has a pluggability, so you can add additional things. And you will type Go run, Go install, Go build, Go test, all over through the course of your development all the time. And it is quite nice that whole things are gathered in one place.
Okay, so we don't have time to show you everything about Go, so decided to choose some things that we personally very like. We think that they are the most interesting. And the first of them is the ability to return multiple values. As you can see, we have a function called swap that takes two parameters, x and y, both are strings. And what we are saying there is that this function is returning two values, both of type string. In the body of that function, we simply swap the arguments. And as you can see in the main function, what we are saying there is simply, okay, Go, create two variables, a and b. And what is very important here, that you don't need to say what type of those variables will be. The Go compiler will know that from the definition from swap function. This is also very important from another reason. In Go, there are no exceptions. You cannot throw an error.
There are no exceptions here.
Yeah, no exception at all. So how can you indicate that something went wrong? You can use the old C style, return negative value. Yeah, that's one way. But what's the most commonly used pattern in Go is that you simply return another value of a built-in type error. And we'll show you an example of that pattern later. So, as Adam mentioned, there are no objects no objects in Go. So, but
no classes.
No classes, in fact. We are just a beginner, so. But what you can do in Go, you can create a type. For this example, there's a vertex type, and it's a structure with two attributes, x and y. And what we can do in Go, you can attach a function to every type in Go. So in this example, we are creating an ABS function, and we are attaching it to a pointer to vertex structure.
Pointer warning, pointer warning.
Yeah, there are pointers in Go, but there are no pointer arithmetics. So keep your fear down. You can use it. You will be fine.
But it's also interesting here, and what is also nice in Go, that by convention, objects exports only those elements which are starting from which name is starting from the uppercase. It is one among many things which helps to keep Go code concise and small.
Yeah, and the main function is quite usual. You simply create a new variable of the type vertex, and as you can see in the next line, you simply call a function on it. So
I cannot imagine any modern presentation about language without microservices now. So there should be also reactive programming. But everyone nowadays are creating microservices. In the past, it was called the names were different, but the whole thing. So it's important, so we thought that we will also show you some of the microservices. So this is our first microservice, and in fact HTTP server, which is just printing a hello world to the user. So in first line of the main function, we are attaching a request handler to the root context. So this handler is only doing one thing, it is returning the particular string. In the next line, we are starting the HTTP server under the certain port, and the whole program, if it runs, it serves the requests which are coming towards this address and context. So just to give you a comparison of the thing which is striking me quite heavily, this is one of the major languages which is used nowadays, and exactly the same thing implemented in Java. So Java is verbose, everyone knows that, but I think that I found something which is nicer, and Go is nice. So apart from those examples which we are showing you here, we were also working on some projects with Go, and after finishing them, we decided to create a small project which will showcase the features which are the most relevant in our opinion. We were looking for inspiration, what kind of project it should be. And there was one guy in the pop culture who was given inspiration all over the place. And if he would be in IT, he would be a star, and I'm sure of it. So we decided to create a Coelho project. And we'll give you the link afterwards. So Paolo Coelho project is, in fact, intends to gather all the wisdom of Paulo Coelho in one place. So we are aggregating information, quotes from Paulo Coelho from different sources, and we are giving it to you as a very useful JSON. So rocket science, yeah, I know. Here is some more rocket science. Parsing JSON. You cannot write a modern application without parsing JSON. And as with every strongly typed language, if you want to parse JSON, you need to create dedicated data structures. And here is our quote structure. This part with JSON after the type of the variable is optional. Go has a pretty nice reflection mechanism which allows to recognize the name, to associate the name of the JSON key with the name of the variable. So, as I said, these are optional. If we go afterwards, if we go underneath to the function, we will see the example of the convention which was already mentioned by Tomasz. So the error handling is done through adding additional arguments to the return arguments list. And one thing which is also done by convention in Go is that you cannot have unused variables, you cannot have unused inputs, you cannot have cycles in your impulse dependencies. So this will all cause the compilation error. And as you see here, this underscore in the first line is the way to deal with those variables which we are not willing to cope with. So you are using underscore to ignore the potential error returned by the function which is opening file. Another nice thing is the defer keyword. You can defer the file close till the end of the function. And what is neat here is that you have the open and the close next to each other, so it is easy to read and it's easy to get an overview of the whole routine. If we would go to this line with if statement, Go allows you to have initialization statement for the if expression. So we are decoding our JSON, and the variable with the error is then checked, and the appropriate error will be returned to the client if something will go wrong. The next thing, which is quite neat in my opinion, are the way how interfaces works in Go. So in Java, you need to explicitly say that given class implements given interface. In Go, it is done on the other way around. So if you have a method, a function, which has a signature which is exactly the same as the interface, it simply means that this type, this object, is able to cope with this interface, has this interface. So it is particularly great when it comes for testing. So you can easily change the real implementation, for example, in this case, the Twitter client, which is calling the Twitter API, with the fake one, which allows you to test your business logic. And as you see here, the example of a test, which is written in the built-in Go testing framework, allows you not only to test things, but also to benchmark your code for performance. And the nice thing is that the whole thing is built in, so the whole language was created with the testing in mind.
Yeah, another feature, and I think that's the most important and my favorite one, is a built-in concurrency model. So what is concurrency? I will quote Rob Pike, who said it's a composition of independently executing computations, and everything should be clear now. So in other words, it's a model of software construction. So you split your problem into smaller chunks that work together but independently. You have to remember that they do not need to run in parallel. So what is a Go routine? Go routine is simply a layer of abstraction of that idea. It's a separate, lightweight thread of execution. It's not an OS thread. It's simply a way you can tell to Go compiler that you have a function that can run concurrently with other functions. And the Go routines in Go are very light, so you can put 10 of thousands of Go routines on a regular machine. Let's look into an example. What you want to build here is a sophisticated algorithm of sorting numbers. We call it Sleepsort. And the idea is we want to create a separate thread for every number that array, wait the amount of time equal to that number, and then print it back into a console. And that version you are seeing right now won't work. We are in a single thread environment. We'll simply get the numbers exactly in the same.
It might work if the input array will be sorted already.
Yeah, that's the only way it can work. But you will get numbers in exactly the same order that we put it inside that array we want to sort. How can we change that code using the knowledge of concurrency built in Go to make it work? Well, the answer is very simple. You need just one keyword. Once again? Yeah.
Once again.
Okay. There's a Go keyword at the beginning of that invocation of Sleepsort function. And what it does, for every number, when we are invoking a function, the Go compiler takes that invocation, puts it on its own stack, and loops for another number. So you might think, yeah, that sounds fine, it should work. Unfortunately not. The way Go is defined, when the main function returns, the whole program exits. So
I guess they know a bit of a Go. You can ask questions also to them.
oh, okay, so how can we fix it? Okay.
I was wrong, sorry, Tomasz.
No problem, I will answer my own question. So one way we can do it, we can put another slip at the end of that function that will wait till all Go routines finish, and then we are fine, we have our array sorted. But you can see that this is not the prettiest solution to that problem. So is there anything else you can do, Adam?
Oh, that's, I don't know. Yeah, there are channels, and channels are pretty neat abstractions, which is introduced in Go to handle synchronization between the processes. So think about channel as a synchronized message queue, which are sending events between the Go routines. And here's the Sleepsort once again, rewritten with the support of channels. As you see in the first line, we are declaring the variable channel. Channels are like every other objects are, their type is also checked. So if you take a look at the second line of the main function, we are creating channel which will handle integers. And this make function is one of the things which I really don't like in Go. So in Go you have two initialization functions. Most of the objects are instantiated using the new operator, but slices, channels, and maps are created using make. In my opinion, this is a sort of a, I don't like it. Okay, so we are creating this channel, and we are passing this channel to our sorting function. When this complicated, sophisticated sorting algorithm is over, it is passing the number back to the channel. So in the last line, we are aggregating all the results, reading that value from channel, and returning this to the client. Just to briefly refer to our enterprise Coelho project, we are using channels to aggregate the quotes from different sources. As you see here, we have our own local collection of our favorite quotes. We are also following Paul on Twitter, and we are from time to time adding some random hard quotes just to give some spice to this. So if you are interested in our small effort, our small experiment, you can import the whole package using Go dependency management mechanism. It works like that. It requires Git and Mercurial to be installed on your machine, and it simply goes to the repository, downloads the source code, compiles it, and that's how the whole thing is installed on your machine. So as we said, we are interested in investing more of our time in Go. And if you have a large code base written in some language, you would like to have a tools to monitor the quality of the whole code. So we were looking from one side on one side we were looking on the standards which are in place. On the other side, we were looking for the tools which allows us to monitor the compliance to the standards. So CoFMT is once again one of the examples of how this language was designed. So it doesn't give you too much choice in some obvious things. So I am sure that everyone had this kind of coding start and discussion because they are present in every development team. In Go, there is one coding standard, so you don't have to bother with choosing the one. It was already chosen. So, and apart from this, there are also other tools, so all kinds of linters, all kinds of tools which are investigating your abstract syntax tree of your code and looking for potential problems. So GoLint, GoVet, and also tools which allows you to calculate the coverage of your code if you have tests. We have also done some experiments, and we took a look at, we wanted to associate our GitHub repository, our project, with the one of the continuous integration services which are up there. We've chosen Drone.io because it is written in Go, but also Travis and Wrecker are supporting Go builds. And we've connected this with Coveralls, which is a pretty nice service which allows to visualize the code coverage of your code, which is stored in the GitHub repository. And the whole thing works quite neatly.
So the question we started with was, are you ready to go? And we think that every tools that you need are there. And the question you need to ask is, are you ready? Are you ready? So some pros for Golang. First of all, it's made by Google and it's used by Google internally. So there's a huge thing to start with. Also, as we just showed, that language is more readable and concise. And I would even say that it's fun to write.
I'm grumpy, so no fun tonight.
It also has a powerful tool chain. Everything you need is just a command away with a Go that you have at the beginning. And it really has a fine dependency management. You just need a link to a repo.
The Go has a really nice feature. It has a language specification, which is available since version 1.0. And the creators of language are promising you the backward compatibility, of course, till version 2.0, but it won't happen soon. And this, comparing to other modern languages which are currently very rapidly developing, for example, Scala, is a completely different approach. Because in Scala, from release to release, the backwards compatibility might be broken, and you may end up in having libraries which are unable to cooperate with each other.
Yeah, there are some cons. So first of all, you have to decide if that language fits inside your project or company. In Allegro, we have to satisfy some internal requirements to use other languages, and we are not there yet, but we hope we'll be soon. Another thing is that Go uses quite naive approach to garbage collecting. It's definitely not as good as in JVM, but they are working on it.
And from my point of view, and to some extent, from the point of view of Allegro, which is now investing a lot of effort in Java and JVM-based language, Go is not a JVM language. So the integration of Go with C and C++ programs is very nice, but the integration with the JVM language might be a bit more complicated. So this is also, in fact, an advantage of Go because it gives you different things, but it would be nice to have a Go as one of the JVM languages, definitely.
So what we are basically saying is go and try it.
It may hurt in the beginning, as you see, but it's worth. Any questions? There is one.
Hey, I have a question related to Go routines. So you had an example where you're spawning new Go routines. How can you tell whether this has already completed or not?
Okay, so in general, you saw that example, the first implementation of the Sleepsort. We had to add this sleep in the end. So the main thread does not have any information about those Go routines, what is the level of them, and the convention is that they are finished when the whole program stops. So the only thing which I am aware of are the channels or other ways to synchronize those. So there are other constructs like, for example, wait group, which you can use to wait for the Go routines to finish.
Can a Go routine crash because of some exception?
Yes, it can.
And what then? How do you know?
In general?
No, in this main thread, how do you know that your Go routine that you spawned has crashed?
I don't know. That would be terrible. Certainly, you can add a timeout for Go routines. So time sleep is one thing, but when you're spawning when spawning Go routines in your program, you can specify the time mode. If you have this approach for gathering results, which is related to counting the Go routines which are coming into your flow, you can also time mode them.
In the first example that you gave of writing a web server, it looked like you were modifying, each time you were adding a new handler, you were modifying some kind of mutable global variable. If that's the case, how would you say have two different web servers in the same application running on two different ports and serving two completely different applications?
Okay, so as far as I know, this is the default instance, but you can create the object of a HTTP server. This is a simplified approach.
So you could say new HTTP and then you'd have two of them.
Something like that.
Got it, thanks.
You said you use it in your company. How complex are your systems you built with Go?
We have
and
created.
Maybe a second question. Yeah. I heard some time ago that Go is lacking generic types. So how easy it's to write some patterns or some patterns of code that repeat often, so building libraries and so on, if you encounter some problems with it or not.
Now, we have, apart from those simple toy projects, we have just deployed one service inside of our production environment, and it was quite simple. As for your second question, we are beginners, so that is the only answer I can give you. We haven't encountered this problem so far. Thank you.